Right, good morning. Thank you for joining. Let us begin our session. So we were discussing about Kubernetes. So in the Kubernetes, in the last sessions, like we understood what is pod ML, how to write a pod ML, how to create a pod. And for practicing the Kubernetes, like we have installed Docker Desktop. The Docker Desktop, how can we see whether the Docker Desktop is running or not? You see here the hidden icons. You can see the hidden icons. And this is the symbol where you can find whether the Docker desktop is running or not. So once you find the Docker desktop is running, or otherwise on the desktop, you might be seeing the icon for Docker desktop. You can double click on the Docker desktop also. You said, I'm just trying to open the Docker desktop from here. When I double click on it, I can able to see the Docker desktop here. Okay. So how to connect to this Kubernetes? Okay, this is a Docker desktop. How we are practicing Kubernetes here in the Docker desktop? So we can directly connect. Usually for enabling the Kubernetes, we have already seen the option. We'll need to go to the settings, and under settings, we have Kubernetes option. So just need to select Kubernetes. By default, the Kubernetes is disabled. So if we wanted to practice Kubernetes, just enable the Kubernetes and apply and restart. That's it. So Kubernetes will be enabled. And now I'm just going to connect to the Kubernetes. For connecting to the Kubernetes, here we have a terminal option. Just click on the terminal. So in the terminal also, we have multiple options here. I'm just closing it. In the terminal also, we can see multiple options. So on the when I click on the plus symbol, like I have an options like Windows, the Windows command prompt. I can also connect through Git Bash. Like that, I have several options. Okay, I'm just adding the plus symbol. So even if we go to the drop down also, it will show the three options like Windows PowerShell command prompt and Git Bash. I'm selecting Git Bash. I'm starting a new terminal. And we know the very first command that we run to see whether any pods are running here or not is we use a command called kubectl get pods. Yes, I can able to see some pods running here. So when I'm running this command kubectl get pods, I can see these are the three pods running. And at the same time, I also came across the command called kubectl get nodes to see how many nodes are running. Currently we have only one node, which is called Docker Desktop cluster, Docker Desktop with a single node cluster. This is the one it is shown. Fine, if I want to delete this one, and if to see what are the YAML files that we have saved here, we can see there is an YAML file called pod.yaml, and there is also an YAML called replication controller.yaml. And if three pods are running, see, actually we have implemented this with the help of replication controller. See here, when I'm running this command, kubectl get pods, we can able to see three pods here. And these three pods are running. And when we can verify what object is running, kubectl get replication controller. We have a command to see the replication controllers running. Kubectl get rc. So let's go ahead and run this command kubectl get rc. We are in the Docker desktop. I just opened it and I'm just running a command called kubectl get rc. RC stands for replication controller. Okay, kubectl get rc. The short form we are calling it as rc. And when I run kubectl get rc, we can able to we can able to see the replication controllers that are running. So we have one replication controller running. So that is Nginx one. How many pods are running here? Three pods are running here. And even we can able to see just by running a command called kubectl get pods, I can able to see 3 pods are running. But if I delete any pod, let me show you. If I delete any pod, usually in Kubernetes, if any pod is to be deleted particularly, if I want to delete any particular pod, we just give this command kubectl delete pod and this particular one, name of the pod. Okay, we need to give the name of the pod. And if I would like to delete the pod, you see the pod is deleted. Remember, what is the pod that is deleted? A pod ending with 29 is deleted. And if again I run a command called kubectl get pods, I can able to see a different pod which is started at 10 seconds ago. It started at 10 seconds ago. So pod is actually, we can see like the pod has started 10 seconds ago. The age of the pod is 10 seconds. You see, 3 days ago, we have started this replication control and still the pods were running. Just now I have deleted one pod, and in the place of the old pod, the new pod came into the picture. The new pod came in the place of the old pod. So even if you run a replication controller, even if a pod is deleted, if a pod gets deleted because of some issues, or if you deleted the pod, a new pod will be created in the place of the old pod. Even if we delete all the 3 pods also, all the 3 new pods will come. Okay, all the 3 new pods will come. So that is this is actually, this is one the advantage of Kubernetes. Like whenever a pod is deleted, a new pod will come and run. A new pod will be coming into the picture. Okay, that is how the replication. I told you, right? So when we discussing about the Kubernetes architecture, there is a component called controller manager. There is a component called controller manager. Controller manager is mainly for what? So it is mainly for looking after whether it has the desired number of pods or not. Okay. And if you see, I am just giving a AML file, right? We are just giving an AML file. First, we are writing an AML file. With the help of AML file, we are creating pods and all. So if I see the replication controller.aml, I'm just using cat command. Okay, using cat command to see the replication controller.aml. What are the contents present here? So we are just writing this replication controller AML. So this is the AML file format. We understood actually what is API version kind. Okay, all those things. And if we remember here, we are specifying the number of replicas as 3. We are keeping the number of replicas as 3. That's the reason why we were able to see 3 replicas. Suppose if I want to make the replicas as 4, or if I want to reduce the number of replicas as 2. So what I can do is I can edit the same file. Okay, I can edit the same file. I'm using a command. I'm editing the file. Okay, vi space replication controller.aml. I'm editing the file. And what I'm doing is I'm going to the replicas section where we are specifying the number of replicas. I'm just modifying the number as 2. Okay, escape :wk. I'm saving the file. I've saved the file. I'm using vi command to edit the file and to save the contents. So now you can see, just I have edited the contents. Okay, I'm using cat command to see the contents. Earlier the number of replicas was 3. Now I have modified the number of replicas. Now the number of replicas are 2 only. We have only 2 replicas now. So, but when I run the command called kubectl get pods, it will be usually 3 pods running. Why? Because we just modified the AML file. We did not apply it. We just modified the AML file. We did not modify. We did not apply yet. So we need to apply. How to apply? There is a command. So the command we use to create kubectl create -f replication controller.aml. So this is the command which will creates the replication controller. This command will create the replication controller. But if the same file is edited, if the same file is modified, we need to run a command. We don't need to use create command again. Once it is created, we should not use create command again. So we should use apply command, kubectl apply. So if any AML file is modified with some contents, and again, if I would like to apply the changes, So usually the command I should run is kubectl apply -f replication controller.aval. This is the command we should use. Okay. And you see here, it is showing like some warnings it is showing. We'll discuss about these warnings later, but we see here the replication controller Nginx is configured. I've just updated the YAML file and I applied the configuration. How to apply kubectl apply -f, the same file name. So for the first time you are creating, we need to run a command called kubectl create. For the first time we are creating, that time we need to run a command called kubectl create -f replication controller.yaml. Okay. So whatever the name of the YAML, that the same file we will use. So now let's try to see the number of pods running. We just modified the replication controller, right? And in the replication controller, earlier three pods were running, three pods were running. Now we just made it as two. So now we could able to see only two now. We can see only two now. We don't have three. We have only two. Here you can modify. How to modify still? If you want to modify, you can edit the file. If you want to see the number of replicas, if you want to edit the number of replicas, you can modify the number of replicas as 4, escape, shift colon, WQ. Once after applying the change, once after modifying the file, you need to run a command called kubectl apply, kubectl apply, right? So after applying, you can run a command called kubectl get pods. You could able to see the 4 pods are running here. Yes, we have 4 pods running. This is how actually we can increase the number of replicas. The advantage of having the replication controller, the advantage of having the replication controller is usually, so let me show you. Okay, let me come across. Okay, usually we discussed about, we are now talking about Kubernetes objects. As I told you, there are many Kubernetes objects. Okay. So the basic thing that we need to understand is like we need to understand what are all the Kubernetes objects that we can create. We can create a pod. Okay. We can also create a replication controller. So first of all, we need to understand the differences between them. We can create replication controller. We can create replica set. We can create replica set. These are the Kubernetes objects that we can also create deployment object. There is a difference between each and every object. Okay. There is a deployment object. We have an object called ingress. We have an object called ingress. We have an object called service. We have an object called service in the Kubernetes. Okay. Pod replication controller, replica set, deployment object, ingress service. We also have an object called HPA, horizontal pod autoscaling. We also have an object called HPA. HPA stands for horizontal pod autoscaling. We will discuss about all these things. We understood the YAML file format of the pod. How can we create a pod by writing the YAML? And I've also shown you how to create a pod with the help of commands also. With the help of commands also, we can create pod. We understood that, but with the help of YAML file, how we are creating a pod, we understood. So where we are getting all these YAML files, you can directly go to the Kubernetes documentation. Okay. What is the Kubernetes official documentation? You can go to kubernetes.io. You can search for pod. If you search for pod, then you can able to see the YAML file. You're able to see the YAML file of the pod. So this is the YAML file. So we came across the YAML file. What are the contents of the YAML file? Everything clearly. Let me go through once again. So pod is the smallest object that we can create in the Kubernetes. Very smallest object that we can, smallest and simplest object. Okay. Pod is the smallest and simplest Kubernetes object that we can create. Okay. So this is an example. Okay. Whatever the YAML file that we are looking at, that is an example YAML file. Let me show you. This is an example YAML file which clearly shows. Okay. This is an example file to create a pod. This is an YAML file to create a pod. And we are using an Nginx image. We are using an Nginx Docker image. So meaning what we are going to create is we are going to create an Nginx pod so that Nginx will run as an Nginx web server. We are going to run an Nginx pod. For that, we are taking this an example. Okay, I'm just copied this example from Kubernetes official documentation. You can see here what are the contents that we have. Let's see the YAML configuration breakdown. We already seen it. We have already understood like what are the contents of the YAML. But anyhow, if this is an YAML file, you see the top level elements that present in the YAML is API version, kind, metadata, specification. These are the 4 top level elements. And if you want to look at the breakdown, what is API version says, let's understand what is API version and kind. API version specifies the version of the Kubernetes API. So whenever you create a pod, you need to use we need to use Kubernetes API. So this Kubernetes API is different for pod. It is different for deployment. It is different from one to another. So if you are creating a pod, you need to understand the Kubernetes API. API stands for Application Programming Interface. The Kubernetes API you need to use here is V1. The API version you need to use here is V1 for the pod. Okay. So kind is pod. Kind specifies the type of Kubernetes object we are creating. In this case, in this example, we are mentioning pod is the Kubernetes object we are creating. And then the next section is metadata. We are done with this API version and kind, right? So we need to understand what is this metadata. So this metadata section, if you see, metadata provides metadata, additional information about the resource. Okay, additional information in the sense like the name of the pod. What is the name of the pod? Okay, anyhow, we mentioned that the deployment, the type of the object that we are creating is pod. We should also mention the name of the pod. The name of the pod is also Nginx. If you look at the YAML file, API version is V1, kind is pod, metadata. Under metadata, we are giving the name of the pod. You see, under metadata, we are giving the name of the pod. Name of the pod is also Nginx. And we have one more section called specification section. This specification section consists, the specification section tells us what we are, I told you, right? It specifies the container related information. The specification section contains the container related information. You see, under the specification section, it is clearly mentioning that we are going to use a Docker image called Nginx 1.14.2. And we are going to create a container inside the pod. With the help of this Docker image, we'll create a Docker container where the Docker container will run inside the pod. So name of the Docker container is also Nginx. This is the container related information, not pod related information. We mentioned like what is a pod, what is the object we are going to create. We are going to create a Kubernetes object. The name of the object is pod. The API version we use for pod is V1. It is different for the other objects. Maybe it might differ from the other objects. But for pod, it is V1. API version we use is V1. This is the additional information, meaning if you are creating a pod, you will specify the name of the pod here. If you are creating an replication controller, we will give the additional information about the replication controller. What is the name of the replication controller? Okay, all the information will be provided under metadata section. Under specification section, we'll provide the container related information. With the help of this Docker image, we are going to create a container called Nginx container. And this container will run inside the pod. As I told you, if I'm creating a pod and if the pod is running, what actually is running inside the pod? Inside the pod, we have Docker container. Inside the pod, we have the Docker container running. With the help of this Docker image, it will create a Docker container, and this Docker container will run inside the pod. And we have one more section called ports. So if we create a pod and if the pod is running, okay, the pod can be accessible. The pod will listen on this particular port. Actually, this is the default port of Nginx. This is the default port number of Nginx. Usually, we specify the port number like this. We give the ports, and under the ports, we will specify the container port. Meaning is this particular pod will listens on the port number called 80. This is the meaning. If you are giving the port number, the meaning of this port is it is listening on, it will listen on the port number called 80. That is the actual meaning of this YAML file. If you understood this YAML file, let's go to the another YAML file. Okay, let's go to the another YAML file which is called replication controller. So what is the difference between pod and replication controller? Why we are going to the replication controller? In the pod, we don't have the section called replicas. So suppose if I want to create multiple replicas, pod YAML doesn't support. That's the reason why we are discussing about replication controller. It ensures that replication controller, what is the advantage with the replication controller? We can specify the number of pod replicas. You see here, we can specify the number of pod replicas. If you want 4 replicas, you can specify. What happens if a pod is deleted? If a pod fail or gets deleted, replication controller will automatically create a new pod. If a pod fails or deleted, the replication controller will automatically create a new pod. And in this replication controller example, we are just taking, okay, this particular configuration, this YAML configuration talks about, okay, this YAML configuration talks about creating 3 replicas. Okay, it is used to manage 3 replicas of the Nginx pod. This YAML configuration talks about managing 3 replicas of the Nginx pod. Okay. Anyhow, we almost understood the YAML file. We know what is API version. We understood what is the kind of the object we are creating. The type of the object we are creating is replication controller. Name of the replication controller is also Nginx. Okay. And here, this is the specification section. Okay. This is the specification section we need to understand. Okay. So let's understand the breakdown here. We understood what is API version and what is a kind. Okay. API version always specifies the version of Kubernetes API that you choose. So we need to choose the version of the Kubernetes API for each object. For pod, it is V1. For replication controller also, it is V1. Version of the Kubernetes API is V1 for both pod and replication controller. Kind specifies the type of the Kubernetes resource. Type specifies type of the Kubernetes resource. What do you mean by this type of resource? Whether we are creating replication controller or which object we are creating. It talks about the particular object. We are creating a pod. Here we will mention pod. If we are creating replication controller, we will write replication controller. And anyway, we understood the metadata also. Metadata provides the additional information, as I told you. Metadata meaning additional information about the resource. So the name of the replication controller is also here. We are specifying the name of the replication controller, name of the replication. This metadata talks about this particular object. If you are creating a replication controller, the metadata section talks about the additional information about the replication controller. So if we are giving like this, metadata, under metadata, name is the only label we are using, then it is nothing but the name of the replication controller we are using. The name of the replication controller is Nginx. Let me go to the next section. This entire section is called specification. So this particular section talks about the desired state, okay, how actually the replication controller is to be. So this particular specification section consists of the container related information. You see, I'll show you. The very first thing, okay, we are now talking about the specification section. The very first thing that we mentioned is replicas 3. Here, under specification, we just mentioned that replicas has 3. What does the replicas say? The number of pod replicas that should be running. If I want 4 replicas to run, I will mention the number as 4. If I want 5 replicas to run, I will mention the number as 5. In this example, it is set to 3. Okay. So the next one. Coming to the next one, we have one more field called selector field. We have one more field called selector. What is the selector says? It defines how the replication controller identifies the pods. The 3 pods are running. Okay, 3 pods are running. So how actually it identifies the pods? So some name we should give for the pod, right? So anyhow, we are giving some name to the replication controller, all these things. Let me open here the example, the replication controller. Anyhow, we understood these three metadata until this metadata. Under the specification section, we also understood why we are using this, the number of replicas we wanted to create. We are now understanding the selector. We have an additional field called selector. Under selector, we are just providing the name of the pod. So the name of the pod is this. The under selector, we are giving the name like this. Okay, app colon nginx, meaning. So this replication controller will identify the pods based on this name. If the pod is having a name like this, if the pod is having a label like this, then it recognizes. Okay. So how anyhow three pods, we are going to create three pods. Under replication controller, we are going to create three pods. We mentioned the name of the replication controller is Nginx. And the replication controller YAML will also have some section called selector. Under this selector, try to understand, under this selector, there is a label, okay? This under this replication controller, we also have one more field called selector. So this selector defines or identifies how actually replication controller will recognize its pods. The replication controller identifies the pods based on this label only, based on the selector component only. So if you see here, it uses a label selector to match the pods. It uses a label selector to match the pods with this name only. If the pod is running with this name, then only it identifies that this pod comes under the replication controller. It just recognizes with the help of this label. So if you don't understand if you don't understand this particular selector now, try to understand under replication and replication controller YAML, we also have a selector field. Under selector field, under selector field, we will mention, you see here, we use some label called, actually selector itself is the label. Okay, selector itself is the label. So under the replication controller, we will be having some selector label, which is used to match the pods. This is the main reason. So it has to identify the pods. Replication controller, how replication controller identifies the pods? If the pod is having some label, then only it identifies. So that's how we are providing the name of the label so that it identifies the pods. Okay. The advantage of this particular one is, the advantage of having this selector label is, so the replication controller identifies the pods based on this selector label. Now let's move on to the next one. We have another section called template. You see, we have a section called template. Under template, we have metadata. Let's understand that one. So template is nothing but the pod template used to create the pods. It is a pod template. So anyhow, it is creating the replication controller. Under replication controller, we will be having some replicas. So each pod should be like this. This is the template of the pod. Template section tells us the template of the pod, how the pod looks like, what is the specification of the pod. So pod should run with the Docker image called, this is the entire information we have already seen in the pod YAML, okay? This is the entire information that we already understood in the pod YAML. We need to understand this template section. The template section defines the pod template used to create the pods. Okay, so usually this entire section will be considered as a single section only. Okay, we have a template section. This entire section will be considered as a single only. You can see here, we open this template section. You see this template section is the pod template. This template section talks about the pod template, meaning pod related information. You see what kind of containers, what is the container that is going to run inside the pod, and what is the information about the pod. You also see here the name of the metadata means the name of the pod. Name of the pod is Nginx. Container related information, Docker image is Nginx. Docker container. This is the Docker image name. This is Docker container name. This is the port number that it should listen. So this specification section we already understood in the previous examples. But we need to understand this template. Additionally, we here that the template is different. Okay, but the replication controller, the template is different. We should consider this entire thing as a pod template, meaning it is going to create a pod with this container related information. And this is the information that it is the additional information about the pod. So it is going to create a pod with a name called Nginx. Also having some labels here. Here also we are having some labels, you see. Metadata provides the metadata for the pods, the name of the pod. And labels, we also have one more section called labels. Labels are the key value pairs attached to the pods. Labels are nothing but the key value pairs attached to the pods. So this is how actually the YAML file will be for replication controller. Okay. Any questions here in understanding the replication controller YAML, pod YAML, all these things? If you are okay with these things, we will go to the further thing called replica set. So in the replication controller, the only thing we need to understand is API version, kind, metadata, specification. These are the common things in any YAML file. But additionally, in the replication controller, we should consider this as a template section. This is the pod template section. Okay. This is the pod template section. Under pod template, we are just mentioning the pod related container related information as well as pod metadata. Okay, and there is a field, one more thing called selector field. We have one more additional thing called selector, based on which the replication controller identifies its pods. So it identifies the replicas based on this name. And how many replicas we need that we are specifying here at the place called replicas 3. So we understood, like if I have an YAML file, how to create replication controller and all, we have seen that. If this is the YAML file, how we are going to create replication controller? We'll just copy this. We have a copy option here. The Docker desktop is running. Please go to the Docker desktop running. This is the Docker desktop. Already replication controller is running. If I want to delete the existing replication controller, I can delete the replication controller kubectl delete -f. We can use a name called replication controller.yaml. I'm just deleting the YAML file. You see, I'm just deleting the YAML file. If the YAML is deleted, we will not be having any pods. That's it. Why? Because everything is there in the YAML. We are maintaining the entire configuration in the YAML. If we delete the YAML file, everything will be deleted. Why? Because based on the YAML file, in the YAML file, we are specifying the number of replicas. If we delete that one, the pods will also be deleted. So if I want to delete a replication controller, this is the command we use, kubectl delete -f replication controller. If I want to create once again, I can create by running a command called kubectl create -f replication controller.yaml. Okay, I can create like this. So for the first time, I can run this command and I can create like this. Usually, yes, it is created. If you want to delete, if you want to see the number of pods running, yes, the pods are just getting created. And if you want to delete, we can delete by running a command called kubectl delete -f. For the first time you are creating, okay, we need to save the YAML file. Okay, I will show you for the other one. We'll go to the next object called replica set. We have an object called replica set. We have another object called replica set. Let's understand. So far, we understood the difference between pod and replication set, pod and replication controller. So to make you understand, okay, in the pod ML, we see like if I create a pod, if I take the pod ML and if I create a pod, only one single pod will be created. If I want more replicas, I will go to the replication controller. Okay, and there is another object called replica set. Let's understand what is this replica set. So the same YAML file format will be same. You see the replica set also API version, kind, metadata, specification. This format is same as, it is common across all the objects. Okay. So the other elements, few elements are getting changed and you won't find much differences between replication controller and replica set also at even. So We saw the same YAML file, API version, kind, metadata, all these things. Okay, there also. But here the only difference is in the replication controller, we use only a single, we have used a single label. Okay, I will show you the difference between the replication controller and replica set. In the replication controller, we have used a single, can you see here? We have a field called selector. Under selector field, we have only one label. We are using only one label. Let's come to the replica set. Here we are using, okay, we are using some labels. Okay, we are using some additional labels. We can also use some additional labels here. Can you see here? We are using the labels like match labels, match labels. Okay, we are using some labels under metadata. We know what is API version. The API version we use for replica set is app/v1. You need to understand this is the API version that we should use for replica set. For pod and replication controller, we just used v1 only. For replica set, it is app/v1. Kind specifies the name of the object you are creating. The name of the object is replica set. And this is the metadata, additional information about the replica set. So the name of the replica set is, the name of the replica set we are creating is front end. This is the name of the replica set. Under metadata, we are providing the name of the replica set. The name of the replica set is front end. And it has two labels. One is guest book. The other one is front end. Okay. It has two labels called guest book and the tire name is, okay. It has two labels. One is guest book. The other one is front end. Like this, we can specify multiple labels. Okay. We can specify multiple labels here. So the only difference between the replication controller and the replica set is, so here we have only limited things. Okay. So how the replication controller identifies the pods based on the label that we are providing. But here you see we have multiple options. It identifies. So here also replica set identifies the number of here also the replica set identifies the pods. It identifies the pods based on few additional things. You see here, we have a component called match labels called tire, the tire name. We have an additional section here, selector, under selector, we have match labels. You see here, the selector, under selector, we are just providing only one single label, okay? In the replication controller, under selector field, we are using only one label. In the replica set, we are using an additional thing called match labels. Under this match labels, you can additionally use any number of labels. So we use tire here. We can also use app name. We can also use any another thing, okay? So whatever the labels that you want to provide. So if you see here we have two labels. We can provide two labels under this match label section. We can provide front end, tire as front end, app name as guest book. So like this, we can provide the match labels, okay? Try to understand. This is the only difference between replication controller and replica set. In the replication controller, there is a very limited, we are using only under selector field, we are using only one label to identify the pods. So the replication controller identify the pods only based on this label. In the replica set, it identifies the pods based on multiple labels. So this replica set identifies, the name of the replica set is front end. It identifies the replicas based on the label name like guest book, or otherwise it will also find out the label name as front end so that it identifies the pods. Okay, it identifies the pods and it will recognize the pods based on these label names. Then this specification section is common. This specification section is common. This is the image name. This is the container name. Okay. And the template says about this additional, this is the specification section. We have already understood. Okay. This template is for the pod. This template is for the pod. So this is the, inside the pod we run, how we create pod. Without image, we cannot create. So this is the image and we are going to create a container inside the pod. This is the container related information. And here we are using a field called selector. Under selector, we have another component called match labels to match multiple labels. Okay, the selector match labels. If you are using selector match labels in the replica set, it doesn't mean that replica set allows multiple match labels to identify the pods. Replication controller will have only single label to identify the pods. Here we can specify only single label to identify the pod. But here we have multiple match labels. We can use multiple match labels to recognize the pods. That is the only difference. Apart from it, everything is same. Apart from it, is everything is same. Let me go ahead and create. This is the replica set YAML file I'm just considering. What I will do is I'll go to the Docker desktop. So now it is deleted. Let me see whether if anything is running here. kubectl get pods. Don't have anything running here. I'm just going to save a file with the vi space replica set.yaml. Insert. Just providing the YAML file here. Escape, shift colon WQ. I'm going to create a replica set. How to create? kubectl create command we use is kubectl create -f replica set.yaml. Here replica set is created. We have a replica set. Let's understand by running a kubectl get pods. We have replica set running. Okay, it is just created. It is being created. So both replication controller and replica set both are same only. The only thing is like in the replication controller, we can view only single label. Okay, we can give only a single label name. So based on that label only, replication controller will identify its spots. But in the replica set, we can give multiple labels. Okay, we have a section called match labels so that we can provide multiple match labels. Based on that, the replica set will identify the pods. That is only the difference. Now you see the replica set is up and running. So far we understood, okay, so far we understood what is pod, what is replication controller, and what is replica set. Understood pod, we understood replication controller, we also understood replica set. Let me go to the deployment object. So let me go to the deployment object, how we are going to create a deployment object. Let's see the YAML file. So this deployment YAML file will be very much similar to the replica set. The deployment YAML file will be very much similar to the deployment. This deployment YAML file will be very much similar to the replica set. So here we can search for deployment object. Otherwise, we will create a new one. Why? Because we need to compare, right? So if you compare, there will be nothing much differences between the replica set and deployment object. Only few. I'll show you what are the. So this is the Kubernetes documentation. Here I'm searching all the YAML files. I'm just going to the deployment YAML file. What is the API version that I use for the deployment? And at least if you see now, you can identify the API version for pod is V1 only. The API version for replication controller is V1 only. The replica set, it is apps slash, okay, it is like apps slash V1. This is the API that we should use. Okay, if you are not aware of what is API, API is an application programming interface. So you will go through the Google and you will understand what is actually an API. For deployment also it is app slash V1. Okay. We are now discussing about this deployment. It is app slash V1. You can see the API version we use is app slash V1. The kind of the object, the type of the Kubernetes object that I'm creating is deployment. And it also have the metadata section. It also have the specification section. Very much similar to the other YAML files. All the YAML configurations will be in the same way only. And here you see the metadata, additional information about the deployment. Name of the deployment is Nginx deployment. Labels, it is providing some label. Okay. And under the specification section, this is metadata, additional information about the deployment, name of the deployment. Okay. And we are providing some labels to the deployment. And you see the specification section. This specification section talks about the number of replicas, and it is also providing the name of the match labels. You see here, match labels. It is very much similar. In the deployment YAML, we will be having a selector with match labels component. Under selector, we are having match labels. So it will identify the pods with this label. If a pod name is Nginx, then it identifies all the pods with the same name. And this template section, we know it is for metadata for the pod that we are creating. This is the metadata. This is the container related information about the pod. So actually, we should consider this entire section as specification section. This is the replicas. Selector is the field which provides the labels for the pod. And the template section, you can consider the template section. Okay. Under this is this is anyhow the container related information we know we are providing. Very much similar to the replica set, nothing more than that. If you look at this YAML, it is very much similar to the replica set. So what are the advantages? What are the advantages with the deployment object? So the deployment object, if we are using a deployment object, we have an advantage with the deployment object is like we can go for rolling updates. There is a concept called rolling updates. There is a concept of there is a concept here in the deployment object which is called rolling update. You see here, I'll try to show you what is rolling update. And to show this, I'll go to this Docker desktop. I'm going to delete the replica set YAML file, kubectl delete -f replica set.yaml. I'm deleting this one. So if I run kubectl get pods, I don't see anything. Kubectl get pods, I don't see anything. Now I would like to create an YAML file with the help of this component vi space deployment.yaml. I'm creating like deployment.yaml. And I'm saving this file, the same YAML file which I've taken here. I'm just copying this YAML. Let's understand what is the advantage of deployment over the replica set. Okay, let's understand what is the advantage of deployment over replica set. I'm just see the YAML file. There is no much differences between the YAML file of replica set as well as deployment. The deployment YAML is very much similar. The deployment YAML is very much similar to the replica set YAML, which we have already seen. Now I am saving this. Okay, I'll show you what is the advantage we have. Escape shift :w cube. I'm saving the file. The same command we use kubectl create. Okay, the command we use for creating any object is kubectl create -f. Since we have an YAML file called kubectl create -f. We have a deployment YAML already. I'm just running this. Deployment is created. And in the deployment, we already seen like only 3 replicas we mentioned. All the 3 replicas are running. Fine. 3 replicas we mentioned. All the 3 replicas are running. All the 3 were started at 6 seconds ago. And there is an advantage with the deployment object like rolling updates. We have an advantage called rolling update. What is this rolling update? We can modify the image. We can modify the Docker image. You see, I'm just editing the deployment file. So in the deployment file, you can see we have a Docker image called Nginx. Okay, we have a Docker image which is running is Nginx 1.14.2. Okay, 1.14.2. But in the Docker Hub, okay, let me go to the public registry called Docker Hub. I'll see what is the Nginx latest version. Nginx latest version, I will see. Otherwise, we can go back to the previous version also. Okay, let me Nginx latest Docker image. Tags. We go to the tags. And you see now, we have a version. We might have different version. So just running like 1.14.2. Okay. So we have a tag like 1.14.2. I'm verifying just 1.14.1, 1.14.3 is there or not. I'm just searching. It is not there. I'm just searching 1.14.4. Otherwise, I'm searching 1.15 is there or not. Okay. So when I'm searching with 1.15, yes, we have 1.15 image. So currently, you see here, I'm just trying to update the Docker image as 1.15. It is already 1.14 running. Now I'm updating the image name as 1.15.2. Escape, shift colon, WQ. And if I apply the YAML file, that's it. The deployment will be updated with the latest version image. Deployment is configured. And you can also see the deployment YAML file. What is the image version that it is using? Image version that it is using is 1.15.2. So meaning what is the rolling update? If I want the higher version of the Docker image, I can update. And if I want to go back to the previous version also, I can go back to the previous version. Now it is 1.15.2. If I go back to the previous version, I can open the YAML file again and I will update the image name as 1.14.2. I will update the YAML file and I will apply kubectl apply deployment.yaml. So that's how we can update the image. So with the help of deployment object, we can go for rolling updates. So without downtime, the advantage of having deployment object is without downtime, the pods will be up and running. Pods will not down. The service will not be down. Okay. So pods will be up and running, but slowly, whenever you update the new image or whenever we update the old image, slowly all the pods will be updated with the image that you are updating here. So that is the meaning of rolling updates. With the deployment object, we have an advantage of rolling updates. Either we can go ahead with the latest version of the image, or if there are any issues with the latest image, we can go back to the previous version. We can go back to the previous version of the image. So we can also use some commands to set the image. As I told you, we can also use some commands also, the deployment itself, deployment of the documentation itself. So we can set, you see, this is the command we use. This is the command we use. And I can simply run the command. Currently, you see here, currently, we have 1.15.12, right? I am just running a command, kubectl set image, deployment, Nginx deployment. What is the name of the deployment? I'm using Nginx deployment. So Nginx is equal to Nginx 1.1.6.1. I'm just updating this. So deployment image is updated. I want to see whether the image is updated here. So in the deployment file, still it is not updated, but it is going to update. Slowly it will update. You can see like kubectl get pods. You see here, a container is getting created some 2 seconds ago, 3 seconds ago. Okay. You see here, earlier a new container is getting created. And if you see the kubectl get pods option once again, I can show you okay, I can show you this pod information. So to see the pod information and all, we can use a command like kubectl describe pod. What is the pod name? This is the pod name. If you want to see whether the image is updated, directly don't go to the YAML file and see. And why? Because we did not edited YAML file and we did not updated it. So we are trying to update without modifying the YAML file. We can do it. So for that, you can write a command, like you can see the command, you can give the command like this, kubectl describe pod, the pod name. So it will provide the information about which image it is using. You can see this is the entire information about the pod. Okay. This is the information about the pod. And if you come down, it has successfully pulled the image called Nginx 1.16.1. Earlier, it was the different version. I have already shown you. Now, whenever I ran this command, kubectl, I ran this command, right? Kubectl set image. We are going to set the image to the deployment 1.16. If I change the image now also, it get updated. I'm just using like 1.15.2. I would like to set this image. Yes, it is updated. And you run kubectl get pods. See the image which is slowly getting updated. Which is slowly getting updated. You see, I'm just running kubectl get pods. Okay, this one is getting updated slowly, one by one. Okay, all the replicas will not be updated with the image. First, one pod will be updated with the image, and then slowly it will get. So I'm just running like kubectl describe command. So hope you understood. If you want to see the related information about the pod, you can run a command like kubectl get kubectl describe pod name, so that it will show you the information. It is pulling the image called Nginx 1.15.2. We are updating the image. We are going back to the previous versions. We can go ahead and update the new versions of the images. So anything we can do. This is how we can use deployment object with the advantage of rolling updates feature. Any questions today? We can discuss. Otherwise, we'll continue in the next session.
No, Vamshi.
Okay, then. Thank you. Please practice.